Okay, I made a mistake recording this video originally, so I have some work up here, and I'm just going to continue off of that. This is my second lesson on derivatives, and I wanted to show everyone a new example of how to find the derivative of a function. And we're going to do this with x cubed. So what I did was I said if our f prime of x is our derivative, there's just the notation for derivative, is that little mark there. So we take this is the definition of the derivative, and we just plug in our x plus h. F of x plus h is going to be x plus h cubed. F of x is just x cubed, so minus x cubed over h. And we have this limit here. Whoops, that's going to be equals. Okay, so equals that. And then I was doing some work here to expand this x plus h cubed. So this is what we have here, x squared plus 2xh plus h squared times x plus h again. And this is what we get out of it. Yeah, so we just multiply this by each term, add it up. This by each term and add it up. And so let's combine these terms here. We have, let's see, we have an x cubed. We'll cross this off. Now, if we have an hx squared in here, there's one. And it's just going to be 1. So this is going to go to 3hx squared. And then our h squared x, we have another 3 of those. H squared x, and finally just h cubed. So we've combined our like terms. Let's go ahead and draw our limit out here and continue on. So we have this drawn out here, and we're going to subtract x cubed, put h on the bottom. So let's do some quick cancellations here. This x cubed on the top is going to get canceled out. And then if we cancel out the h's, we can get rid of 1 here. So we have 3x squared. Let's write this out on the side. 3x squared. And this goes to 3hx plus h cubed. Or h squared if we're going to cancel, sorry. So everything gets canceled out. The h on the bottom goes away. So all we have left is this. Oops. All we have left is this, and then we're just going to apply our limit as h goes to 0 here. So plug in 0 for h. 3 times 0 times x is 0, so that's going to go away. Our 0 squared here goes away. So all we have left is this. There's no h term here, so that stays safe. So our answer is 3x squared. So what we did was we took our function x cubed and we took the definition of the derivative right here, and we said what happens if we plug in this x plus h to our function for x plus h cubed minus the function itself, x cubed, and did this limit. This limit is going to just give us our derivative. And so we did all the math here, all the cancellations, and this is what popped out of it. This is what the limit gave us. And what this is if you were following what I was saying in the last video, if I try to sketch out the graph of this function here, x cubed, x cubed looks something like this. That's pretty rough, but if I pick a point on here, let's say I picked a point 4, and want to find the slope of the tangent line there, our derivative is just, we take this x value, 4, plug it in, so 3 times 4 squared equals 3 times 16. and that's 30, let me just do this mental math, 30 plus 18 equals 48. So the slope of that is 48. We would have to go back and do all of this if we wanted to find the slope right there and plug it in for every number. So we just made a universal function to do the dirty work for us and give us this nice little function. So come back for the next video, because we'll find a way to avoid how to do even all of this using a shortcut. Alright, thanks for stopping by, and enjoy the next video, please.